Today, I want to talk to you about price elasticity of demand. No? Okay, another reference that nobody gets. Why do I even bother? Cross-price elasticity of demand measures the sensitivity in demand for one good when the price of a different related good, a complement or substitute good, changes. Let's get to it. I'm Mr. Racine. Welcome to today's episode of
Economics videos that don't suck.
Legal disclaimer. Cars and gasoline are complement goods in that when people buy cars, they also need to buy gasoline. We know that when the price of cars goes up, the quantity demanded of cars is going to fall. That's the law of demand. As a result, we also expect the demand for gasoline to fall. If people buy fewer cars, they're also going to buy less gasoline. But how sensitive is the demand for gasoline to changes in the price of cars? We can use cross-price elasticity of demand to measure this concept. Cross-price elasticity of demand, often abbreviated as XED, is calculated as the percentage change in quantity demanded of good A divided by the percentage change in price of good B. You'll notice it's quite similar to our calculation of the price elasticity of demand coefficient. But now we're trying to measure how much is the quantity demanded of one good change when the price of a different good changes. Notice with cross-price elasticity of demand, we also don't take the absolute value, as the sign of this coefficient will be important in telling us the nature of the relationship between good A and good B. In the case of cars, if the price of cars goes up from $20,000 to $25,000, this would represent a 25% increase in the price of cars. As a result, people are going to buy fewer cars. That's the law of demand. It should follow then that they're also going to buy less gasoline. Let's say that this gas station goes from selling 1,000 gallons of gas a day to 900 gallons of gas per day. That would be a 10% decrease in the quantity demanded of gas, or a negative 10% change in the quantity demanded of gas. The cross-price elasticity of demand coefficient would then be calculated as negative 10%, the 10% decrease in quantity demanded of gasoline, divided by 25%, the 25% increase in the price of cars, which equals negative 0.4. Notice that cross-price elasticity of demand between cars and gasoline is negative because an increase in the price of cars, a positive percentage change in the price of cars, has yielded a decrease in the quantity demanded of gasoline, or a negative percentage change in the quantity demanded of gas. A negative number divided by a positive number is a negative number. The cross-price elasticity of demand coefficient will always be a negative number for complement goods. What if the price of cars decreased by 30% and as a result, quantity demanded of gasoline increased by 45%? Cross-price elasticity of demand would be calculated as 45% divided by negative 30%, or negative 1.5. This again is a negative value because a positive value divided by a negative value is negative, which again indicates that cars and gasoline are complement goods. Cross-price elasticity of demand is negative for complement goods because when the price of good A goes up, people buy less of good A, so they also buy less of good B, so the quantity demanded of good B goes down. And when the price of good A goes down, people buy more good A, so they also buy more good B, so the quantity demanded of good B goes up. The price of good A and the quantity demanded of good B are always moving in opposite directions, so cross-price elasticity of demand for complement goods will always be negative. Coca-Cola and Pepsi-Cola are substitute goods in that they serve primarily the same purpose. If the price of Coca-Cola goes up, we know that the quantity demanded of Coca-Cola is going to go down. That's the law of demand. We would also then expect the demand for Pepsi-Cola to increase as well. But how much does the demand for Pepsi go up when the price of Coca-Cola decreases? Is the demand for Pepsi very sensitive to changes in Coca-Cola or not so much? We can again use this idea of cross-price elasticity of demand to better understand what's going on here. Let's say that one can of Coke goes from 50 cents to 85 cents. This would represent a 70% increase in the price of Coke. You could go crazy over the price increase, or you could start to buy more Pepsi. Let's assume that people are rational and they start to buy more Pepsi. The quantity sold of Pepsi in this convenience store increases from 100 cans of Pepsi to 135 cans per day, or a 35% increase in the quantity demanded of Pepsi. Cross-price elasticity of demand between Pepsi and Coke would be calculated as 35%, the increase in quantity demanded of Pepsi, divided by 70%, the increase in the price of Coke, which gives us 0.5. Notice that cross-price elasticity of demand between Coke and Pepsi is positive. And this is because, again, an increase in the price of Coke, a positive percentage change, has led to an increase in the quantity demanded of Pepsi, also a positive percentage change. When you divide a positive number by another positive number, you get a positive number. Duh. If the price of Coke fell by 20%, we would expect people to buy more Coke and less Pepsi, with some people substituting away from Pepsi to now the relatively cheaper Coke. Let's assume that the quantity demanded of Pepsi falls by 10% as a result of this fall in the price of Coke. Cross-price elasticity of demand would be calculated as negative 10%, the 10% decrease in the quantity demanded of Pepsi, divided by negative 20%, the 20% fall in the price of Coke. Negative 10% divided by negative 20% yields 0.5. A negative number divided by a negative number is a positive number. That's weird, but it is. Again, cross-price elasticity of demand between Coke and Pepsi is positive because a decrease in the price of Coke has led to a decrease in the quantity demanded of Pepsi. For substitute goods, cross-price elasticity of demand is always going to be positive. When the price of good X goes up, people buy less of good X, so they buy more of good Y. The quantity demanded of good Y also goes up, both positive percentage changes. When the price of good X goes down, people will buy more of good X, so they buy less of good Y, a substitute good, so the quantity demanded of good Y goes down. Both of these are negative percentage changes, which yields a positive cross-price elasticity of demand coefficient. Let's say that the price of peanut butter increases by 10%, and as a result, the quantity demanded of jelly falls by 20%, and the quantity demanded of crackers falls by 1%. Cross-price elasticity of demand between peanut butter and jelly would be calculated as negative 2. Cross-price elasticity of demand between peanut butter and crackers would be calculated as negative 0.1. Cross-price elasticity between peanut butter and jelly and between peanut butter and crackers is both negative numbers, indicating that peanut butter and jelly are complement goods and peanut butter and crackers are complement goods. But the absolute value of the cross-price elasticity of demand coefficient between peanut butter and jelly is much higher than the coefficient between peanut butter and crackers. This indicates a much closer relationship between peanut butter and jelly than peanut butter and crackers. The higher the absolute value of cross-price elasticity of demand for two goods, the more closely related those two goods are, either as complement goods, meaning they're consumed together very often, or as substitute goods, meaning they're really very, very close substitutes, almost identical. Okay, so this has been cross-price elasticity of demand, which seeks to measure the sensitivity and quantity demanded for one good when the price of another related good changes. Cross-price elasticity of demand is calculated as the percentage change in quantity demanded of good A divided by the percentage change in price of good B. No absolute value this time. It could be positive or negative. Cross-price elasticity of demand for complement goods is negative, because when the price of good A goes up, the quantity demanded of good B goes down, and when the price of good A goes down, the quantity demanded of good B goes up. Cross-price elasticity of demand for substitute goods is positive. When the price of good A goes up, the quantity demanded of good B goes up, and when the price of good A goes down, the quantity demanded of good B goes down. The bigger the absolute value of the cross-price elasticity of demand coefficient, the more closely related those two goods are. Next time, we're going to look at what happens to quantity demanded of different goods when consumers earn more income. If your income doubled overnight, would you go to more movies every week? Would you buy more shoes in a month? Would you buy more toothpaste in a year? To better understand this, we can look at the concept of income elasticity of demand. See you there. Hey, what's going on? I hope you liked this video and it helped clarify some of the stuff you're working on in your current economics studies. If you're looking for more resources to help you with AP Economics, IB Economics, Intro-Level University Economics, economics teaching resources, go check out our website, Economics Videos That Don't Suck, evtds.com, for access to our entire catalog of economics videos, as well as practice questions, answers, and even entire mock exams. 2, be sure to subscribe to this channel, Economics Videos That Don't Suck, so you can get immediate access to all of our new videos as they're released, probably mirroring your economic studies right now.